Good morning. So now we continue our lesson. So trigonometric equations is the title of today's lesson. So what do we mean by a trigonometric equation? Let me just review a little bit about what do we mean by an equation. So in mathematics, we have two words. One we call identities, and then another one we have equation. Yes, they have some similarities and some differences. So when I have an identity, I should have equality sign. When I have an equation, I should also have an equality sign. Yes? And then I have some variables involved in both of them. But the difference between identity and equation is that an identity is an equality which is true for all possible values that we assign for the variables. Okay, for example, we can say x plus 1 squared is equal to x squared plus 2x plus 1. So you see, we have equality, we have one variable here, but for all the assignments to the variable x, if you calculate the left-hand side, it turns out to be equal to the right-hand side for the same value of x that you have used for the left side, yes? This is called an identity. And we usually don't say solve the identity, we say prove the identity or show that the identity is true. But let me, for example, if I give you 2x plus 1 equals to 3x plus 7, again, I have equality sign involved, I have one variable involved, but this is not always true, yes? If I choose, for example, x equals to 0, the left-hand side becomes 1, the right-hand side becomes 7, yes? But if I choose what? If I choose x to be minus 6, this will work. If I choose minus 6 here, it becomes minus 12 plus 1 is minus 11. This is also minus 11, and it becomes equal. So an equation is also an equality involving one or more variables, but the equality is not always true. We want to find for which values the equality holds. And this we say solve equation, okay? We don't say show. So this is the difference between identities and equations. And when we say the word solve, we don't just mean find one possible answer. But in the word solve, it means find all possible answers, all possible numbers that if we replace the variable with those numbers, the left-hand side becomes equal to the right-hand side. Yes? Okay, so that is the main difference between an identity and equation. Now we have an adjective here, trigonometric. It becomes more or less clear that trigonometry should also somehow be involved. But we say an equation is a trigonometric equation in which the unknown is an angle. Okay, so for example, if I say sine of x equals to 0.5, this is a trigonometric equation because we have equality sign, we have an unknown, but that unknown is an angle. So this is called a trigonometric equation. But for example, if I write 2x plus 1 equals to sine of 45 degrees, even though you see equality variables and you also see trigonometry involved, but we don't call this a trigonometric equation because the unknown that you have is not an angle. Yes? So this is just a normal equation. So if I ask you to solve that, you will consider this is a number and then you look for x. For example, you move 1 to the other side. So whatever sine of 45 degrees is a number minus 1, and then you want to find x, you divide everything by 2, yes? And that's your answer. So this is not the problem for today because this is simple. But this is the topic of today's lesson. So we want to solve trigonometric equations, okay? Equations means equalities involving one variable here, and the variable in this case is an unknown angle, and we want to find that, okay? But of course, the topic of trigonometric equation might be very broad. There are three fundamental trigonometric equations that we have to learn how to solve, and then we go to a little bit harder problems. Okay, the fundamental equations that we want to solve learn how to solve are these equations. I have sine of an unknown angle equals to a number k. Cosine of an unknown angle is equal to a number k. And finally, tangent of an unknown angle is equal to k. In all cases, we want to answer what x is. So these are fundamental or basic trigonometric equations. So we need to discuss about these three things. And later, if I give you another type of equation, you need to have this in mind, that you have to reduce that equation in some way to one of these equations and then use the knowledge that we developed today to solve it. Yes? That's the strategy. Okay, but before doing that, let me remind you a little bit about what you had before. For example, even in math, I think 2c or 1c, you could solve this equation if I give you this and I write, for example, 0.7. Do you remember if you want to solve that? How do you solve this? Of course, you use calculators, yes?
Sine inverse.
That's called sine inverse. So you just write x is equal to sine inverse of this number, what that is. And then you punch this in your calculator and you get a number. Okay? But of course, calculator will only provide you with one single number. Okay? That is not wrong, but if you remember, I told you when I ask you to solve equation, I don't mean to find one of them, even if that one works. I need you to find all of them. And the calculator will not be able to give all of this to you, okay? The calculator will give you only one of them. Okay, let us take this one and now try to understand what are other solutions for this, okay? So, how should I understand it? So what you do is you try to understand it from the unit circle point of view, because the formulas that we discover today, or yes, we learn about them, are not in the formula sheet, okay? So somehow you need to visualize this over and over again until you learn that. Okay, let me think in this way. This is, I think, a good idea. If I give you a ruler and a protractor. Protractor is the device that you use to measure the angles. Yes, you know that? Okay, so this is the protractor. I don't know if, yes, for example, this. Let me assume that I give you a ruler and a protractor, and I want you to solve this geometrically by measuring, okay, not by calculation. How do you do that? So you are looking for all possible angles for which the sine becomes 0.7. So how do you do that? Using these tools.
Yeah, you find 0.7 on the coordination system.
Which one? X-axis or Y-axis? Why?
Because
sine of an angle is the Y coordinate of the final point. So exactly. So what we do, as you said, I take, for example, my ruler and then put it here. From here to here is 1. Let us say, I don't know, this is, for example, 0.57. 0.7. Okay? Okay, so I used my ruler to measure this length and assume that this is 0.7. Then what to do?
You draw a horizontal line.
Exactly. We draw a horizontal line here. Yes. So that it intersects my unit circle at some points, yes? One thing is clear, yes? Now, what do you do now? Because I want to find x. So far, I measured this length here. I draw a horizontal line. I found my intersection points, but still you didn't answer me. I also need to use this one to find x. So what should I do now? Yes?
Measure the angle.
How? Which angle?
The one on both of them. The one on.
No, there is no angle yet. Before the angle, what should I do? I should draw something, yes?
Yeah, put the ruler that is.
Yes, exactly. So I put the ruler here and connect it to the here. Okay, and then I take my protractor, yes, and measure this angle. Yes, this angle that I measured in this case is exactly what is provided for you by the calculator. Okay, so this angle is one of them. So this is exactly sine inverse of 0.7. This is the number that the calculator will give you. But immediately you'll see that this is not the whole story, yes? Because when I drew this horizontal line, I also got this point. By the way, let me ask you, do you know the coordinates of that point? The x-coordinate we don't know and we don't care, but something we are sure is that this y-coordinate is 0.7. If I ask you the same question here, you can immediately say that the y-coordinate is 0.7. So if I ask you what is the sine of this angle, the sine of this angle is the y-coordinate, so that's correct. But there is also another angle. So if I take my ruler and connect these 2 points, what is the other angle? Can you show me here? So this point corresponds to which angle? This one or the bigger one? The bigger one, because you remember I always told you that you have to start from this starting point. So the other angle is this angle. This angle, calculator is not able to give that angle to you. The calculator only gives you this angle. But how can you find this angle yourself? Yes?
You take 180
Minus that angle. Yes? So do you agree with me? So if I ask you what is the size of this angle and this, how these angles are related, you will tell me that whatever the size of this angle is, the size of that angle is also the same. But I want this angle. So this angle is 180 degrees minus the number that the calculator provides. Yes? Is that clear? So if I ask you how many angles you found so far, you will tell me 2. One of them is 0.7, the sine inverse of 0.7, which will be given to you by the calculator. And if the calculator is not available, you just write it like this. It's enough. But the point is that there is also another angle the calculator is not able to give you. You need to visualize, because this is not in the formula sheet, you need to visualize the second angle is this one. Yes? And this is clear, that is the whole angle is 180. By symmetry, these two angles are equal from the size point of view. So I am interested in that one. So it is 180 minus sine inverse of that. Yes? But so it means that we found two angles. Okay? But is this the whole story? Because I told you that solve means finding all of them. Okay? Calculator in Math 1C gave just one of them to us. By understanding trigonometry in the unit circle, we realize there is one more at least. But solve means finding all of them. Okay, so what does it mean? How should I do that? Yes?
For every 360 degrees, there's
Yeah,
one
so
more
it means that it doesn't matter if this angle, if the sine of this angle is 0.7, if I start from here and go one full round in any directions, I will return to my point. And of course, the y-coordinates will be the same, so the sine of the angle will be also the same. Yes? Is that clear? So this means that if I ask you to solve this equation, you have two possibilities. Either you write sine inverse of 0.7, or x is equal to 180 degrees minus sine inverse of 0.7. But this is not the only angle that you can say. You can say that I can add any integer multiple of 360 degrees to it. Yes? And of course, here you have emphasized that n is an integer. So, okay, you need to write it down. Can I say something like this for this one as well? Yes, because if I stop here, from here I can go full rounds around and return back to the same point. So of course the angles will be different, but the coordinates are the same. So this means that I should also add this one. Yes? So this is the final solution. So in Math 2C, if you want to solve that equation, this is why still some people in Math 4 solve the problem like that. That's wrong, okay? It's not wrong. It is just one possible answer out of infinitely many answers. By the way, do you understand how many answers we got? Infinitely many, yes? For each choice of n. If you choose different values for n, this formula will produce different values for x. All of them are acceptable. And because you have infinitely many integers, you have infinitely many angles generated by this formula for you. Yes? And then the same thing here. If you choose different values for n, this formula generates different angles. And do you agree that these angles are quite different? Because if I ask you where they lie on the unit circle, you only show me this point. All these angles are different angles, but all of them corresponds to the single point that you see here on the unit circle. And these angles are all different, yes, but they all correspond to this point on the left-hand side. Is that clear? So when I ask you to solve this trigonometric equation, this is what I expect you to write. Is that clear? Yes? Yes or no?
Yes.
Okay. And of course, if I give you access to the calculator, might be I ask you to find the answer with 2 decimal points. If I ask you that, then you have to put this number in the calculator and this number in the calculator. Otherwise, you can just keep it like this. Yes, is that clear?
Yes.
Okay. The idea is more or less do the same thing. Understand this structure for cosine and tangent. But before going a little bit further, let me just do some exercises here, okay? So let me write example. Solve the following equations. Okay. And then if you don't have calculator, I told you that for all the exams you will have the formula sheet, and the very last page of the formula sheet contains that table. Yes, table of values. So let me make it accessible for you here. Number one, let me solve very simple equation. So sine of x is equal to 1 over square root of 2. So we want to solve this. When I say solve, I don't mean to do this. You yourself need to understand you have to find all the answers. Okay, so the first thing that you do is to write what? According to that formula, x is equal to what? Sine inverse of that number. Okay, but plus 360 degrees times n. N is an integer. Yes? But in this case, if these numbers are famous, and then you keep it like this and don't continue, you will lose some points, yes? So I don't expect you to memorize the numbers, but I expect you to realize that this is a famous number in trigonometry. Okay, then it motivates you, go back to the table, and then read the angle for me. So can you, using the table, tell me what is sine inverse of 1 over square root of 2?
45.
It's 45 degrees, yeah? So then you have to continue and write x is equal to 45 degrees plus 360 degrees times n. N is an integer, so that is one part of the story. Okay? But the other one will not be given to you in the table. So you need to know from that analysis that there is another angle, then another main angle. So what is the other angle? It is 180 degrees minus sine inverse of 1 over square root of 2, and then plus 360 degrees times n. And of course, again, n belongs to z. And there is, between these two, it is an or, yes? Either the answer is this or the answer is that. But of course, you shouldn't leave it like this. This angle, you read it from here, is 45 degrees. 180 minus 45 degrees is what? 135 degrees plus 360 degrees, and n belongs to z. So when I ask you to solve this equation, I expect you to write this and that. Is that clear? Okay. Now, if it's also, this is not part of the problem, but it is also good to visualize it in your head. So what points we got after solving this equation? we have two angles. These angles are called main solutions. Okay, so the main solutions are 45 degrees and 135 degrees. Why I call them main solutions? Because it immediately tell you which points on the unit circle there. Okay, so one of them is 45 degrees here, the other one is this one. So even though I have infinitely many answers coming from here, infinitely many answers coming from here, one for each choice of n, but it only gives me 2 points on the unit circle. Yes? Is that clear? This is not part of the solution. It's good to visualize. Any questions here? Okay, so let me give you another one. So for example, I give you 2, I write sine. So let me write here 3x. Okay, and then I write here square root of 3 over 2. So we want to solve that equation. Okay, let me tell you something because some students get confused. First of all, you're not allowed to put, what is the meaning of this? For example, by the way, instead of writing this, it's very common that people just write sine 3 of x. You can write using pairs of brackets, but usually your book is not using that, and it's not common to put brackets around that. But if you want, you can do that. So if I give you x equals to 20 degrees, and I give you a calculator, and I ask you to calculate this, how do you do that? Yes?
3 times 20?
Yeah, so this is important to understand that the meaning of this is not 3 times sine x. Okay? Because some students write like that. They think that, okay, this is the same thing as this. I want to make sure that you understand that they are completely different. Okay, here, if I ask you to calculate the value for this, you first put x to be 20, multiply it by 3, it becomes 60 degrees, and then you calculate sine of 60 degrees. And then sine of 60 degrees is there for you, is a square root of 3 over 2. But if I give you this one and then I calculate this, I cannot even calculate it on top of my head. I need the calculator, because if I want to calculate this expression, I need to know what is sine of 20 degrees, which is not in the table, so I have to use my calculator and I get a number. Whatever that number is, then I multiply it by 3. And if you do this, you will see that these numbers are completely different. So first of all, I want you to understand. Okay. Now, can you help me to solve that problem? Yes?
3x equals inverse sine.
Mhm. Yeah, so what you do, you give the role of this x to 3x. Yes? So this is now your unknown. You are looking for 3x. Of course, your final answer should be the one that gives x. But I first find 3x, and then using that, I can find x. So this is an unknown angle to you. Why is this? Why this is unknown? Because you don't know x. So this is your unknown angle. So the unknown angle that you have should be sine inverse of square root of 3 over 2, but plus what? 360 degrees times n. Okay, you can write n belongs to z at the very end. But before continuing, because the problem is not finished, the problem is a new equation. Yes, but this is not a trigonometric equation anymore, because my angle, my unknown is not inside sine or tangent or cosine. Yes? So I need to calculate this, either using the calculator, or this is a famous number, you can read it from the table. What is sine inverse of the square root of 3 over 2? 60 degrees. So instead of this, you put 60 degrees, 3x is 60 degrees plus 360 degrees n. But you are not looking for 3x, you are looking for x. This is a very simple problem. You want to get rid of this 3, you divide everything by 3. Yes? So then it becomes x. But there are two terms to divide by 3 on the right. One of them is this one, you divide, it becomes 20. The other one is this one, when you divide, it becomes 120n. And then, of course, here you write n belongs to z. And then this is the solution. Okay. But is this the whole story? No, you know that this is sine, so there is another alternative, which is 180 degrees minus this angle. Don't get confused, okay? So let us just write 3x. Don't say 180 minus 20. You have to write the unknown angle is equal to 180 degrees minus sine inverse of the square root of 3 over 2 plus 360 degrees. And then, of course, this is the same number. What was it? It was 60 degrees. Minus this one minus 60 degrees is how much? 120 degrees. And then you have also, you also have 360 degrees in. And then you're looking for x. So you divide everything by 3, it becomes 40 degrees plus 120 degrees times n. And of course, you can write n also belongs to z here as well. Yes? Yes?
How did you get 3x is equal to 60 degrees?
This number is 60 degrees. Yes. This is asking you using the table, the square root of 3 over 2. And so you go to this table. On the line for sine, you find the square root of 3 here. And by the way, here, don't use that one. I will tell you what happens if you use this one. So the famous angles, the acute angles, are the one that provide the calculator. If you punch sine inverse of 60, the calculator will only give you, sine inverse of a square root of 2, the calculator will only give you this one and not that one. Okay, so in this one, you see that I took 60 degrees and put it there. Okay, but let me try to understand this. This is the solution is finished here. Okay, but let us try to understand how many points this will generate for me on the unit circle. How many points this will generate. Okay, so let us try to understand it graphically. So if I have the unit circle, so how many points that, for example, let me choose n equals to 0 because I am allowed to choose whatever for n integer n I want. Let me be organized, start from 0. Of course, I should also consider negative values, but my point will become clear shortly. Let me choose 0. What I get 20 degrees, yes? So one angle is probably here 20 degrees. Let me choose n to be 1. What happens? It becomes 20 degrees plus 100 degrees more. Yes? So this means that this is 20 degrees. I go 120 degrees more. So I will reach to 140 degrees or whatever. Yes? This is another point. From here to here is 140 degrees. Okay, but let me give n to be 2. If n is 2, it means that I add 120 degrees even more. So I go 120 degrees more. So it becomes 240 degrees plus 20 degrees. Where is it? 260 degrees, yes? Something like that. But then if I give one more number, it becomes 360 degrees plus 20 degrees. I will end up here. And then I repeat the process. So this only gives me these 3 points. Yes? Is that clear? So the first angle is 20 degrees when I put 0. When I put 1, it is 20 plus 120 is 140. If I put 2, it becomes 240 plus 20, it is 260. 200, am I right? 260 is not here, yes? There might be, I made a mistake, it's here. Yes, 260 is here, sorry. So this is 260 degrees. And then 120 degrees more will take me here, yes? Yes, it will take me here. Because if I put 3, it becomes 360 degrees plus 20 degrees. 360 degrees is here, plus 20 degrees I will go here. So this formula, how many angles are represented by this one single formula? Infinitely many, one for each choice of n. But not infinitely many points are generated on the unit circle. How many points are generated? 3 of them. Yes? So, but now let us look at this. let me change my color here. And I want to do the same thing here for this formula. So the first one is 40 degrees. You don't be worried about the size of the angles. I just want to see that how many points are there. So here, 40 degrees is more or less here. So the first angle that this formula generates gives me 40 degrees. And the next one, I put 1, it becomes 160 degrees. So 160 degrees is where a little bit more than here. Okay. And then the next one, if I put 2, is 240 plus 40 is 280, which is here. And the next one will go back there. So I have 2 different formulas. One of them generates these black dots. One of them generates these green dots. So in principle, I have 6 dots on the unit circle, but I have infinitely many solutions. So they have been grouped into 2 categories, the black dots and the green dots. Yes, this is not part of the solution, but I want you to understand this picture as well. So if I ask you to solve that one, if you stop here, that's complete. Any questions? Is that clear? Okay, so the reason that I'm talking about that becomes clear a little bit after I give you another example. So let me write an example, wait for you to solve it, okay? And then I will summarize everything and we go to the next one. So I want you to solve this problem. And I will choose something similar in the book, but because I don't want you to use the calculator, so let me choose one of these famous numbers. So the problem is this: sine of 2x minus 15 degrees is equal to 1/2. Okay, so the table is in front of you. I want you to solve that. Is that clear what does it mean? It means that I want an angle. I want all angles so that when I multiply them by 2, subtract 15 from them and take sine, the answer becomes 1/2. This is the way that you read it, yes? If I give you x 30 degrees and I ask you to calculate, you multiply 30 degrees by 2, it becomes 60. 60 minus 15 is 45. Sine of 45 is the square root of 2 over 2, which is not this number. So it is clear that 30 degrees is not an answer. I want you to find all possible answers using what you see here. I want you to have a good interpretation of this. Some students still believe that I can take sine of this minus sine of 50. That is wrong. Okay? I give you 2 or 3 minutes is enough probably. Okay. I hope that you could solve the problem. So what we should do first, if you see this equation, what do you write? This is, of course, this is the unknown, but this angle is also not known to you, yes, because x is not known. Okay, so I would say that my unknown angle is equal to what? Sine inverse of this number. And then you know that there is also n times 360 degrees, or I have written the other way around. 360 degrees times n. N is an integer, you have to mention it at the very end. And then using this table, you can immediately see what this number is. What is that? 30 degrees. So you just replace it with 30, then you have 2x minus 15 degrees is equal to 30 degrees plus 360 degrees times n. But now you know what to do. You're looking for x. So you have to isolate x. To isolate x, I move 15 degrees to the right. And then I can do it in my head. So it becomes positive 15 plus 30 becomes 45 degrees plus 360 degrees times n. And finally, to isolate x, I have to divide everything by 2. If I divide this by 2, it becomes 22, 5 degrees. And then this one becomes what? 180 degrees times n. And then, of course, at the end, I emphasize that n belongs to c. Yes, is that clear? How many of you were able to get this answer precisely? Okay, that's good. Thank you. Okay, but you need to know that there is also another alternative. What is the other alternative? You don't really need to write so much. Can you do the next one in your head? You know that it should be 180 minus this angle. But this angle is already 30. 180 minus 30 is what? 150 degrees plus 360 degrees times n. You move it to the other side, it becomes 165 degrees plus 360 degrees n. And then you isolate x by dividing by 2. It becomes what? 82.5 degrees plus 180 degrees. And n belongs to this. Okay, if you have written these two answers, so it means that you were able to solve this problem completely. Is that clear? Okay. And let me give you, because I will give more examples regarding the sign, and that these examples can also be copied for cosine and tangent. So let us emphasize a little bit here. So what about this one? If I ask you to solve this equation, for example, so here I would say 2 sine, I don't know, 2x plus 10 degrees plus 5 is equal to so let me write square root of 3 plus 5, something like this. Okay, I know this is, so let us solve it together. I will give you time for the other practices. So if I want to solve this one, how should I do that? What's the first step? Yes?
The plus 5 on the other side.
You move 5 to the other side, it becomes negative 5, so it will cancel that one. So let us just do it step by step. So this becomes 2x plus 10 degrees is equal to the square root of 3. So I move this to the other side. Okay, what's the next step? Divide by 2, because I want to make it a standard. Standard equations are just single signs equal to a number. So there is a 2 here disturbing me, so I just get rid of it by dividing it by 2. Yes? And then the next one is exactly very standard problem that we learned today. So let us just do it quickly. Okay, the next one is sine inverse of that number. What's that number? Reading the table.
60.
Is what?
60.
60 degrees. Plus n times 360 degrees, or 360 degrees times n. Okay, but then you have to continue. You move this the other side, just do it in your head. It becomes 50, and then you divide everything by 2. So it becomes what? Yes, is that clear?
Yes.
So that's one part of the answer. And the other part is, so here 2x plus 10 is 180 minus this angle you found, which becomes 120 plus 360 degrees, yes? Again, you can do it in your head. If you move it to the other side, it becomes 110. You divide it by 2, it becomes 55. And you divide this by 2 as well, it becomes 180 degrees n. N belongs to C. Yes. Is that clear? Okay. Okay, before moving that, let me give you a little bit surprisingly simple example, because my point is to teach you something else. So if I give you this, solve this equation, a very simple one. Let me see if it works. Yes. Sine x equals to 0. A very, very simple one. the reason that I brought this up right now is because I want to teach you something else. If I ask you to solve this, how do you do that? Just as usual. So what is x? Is sine inverse of 0 plus 360 degrees. Let's read it from the table. These are the numbers that you can immediately imagine. Sine is the y coordinate. You want to have it 0. So it should be 0 degrees. This is just 0 degrees, so you just get rid of it. So this means that x is 360 degrees. Yes? And n belongs to z. And of course there is an alternative. What is that one? 180 minus this angle. But this angle is 0, so 180 minus that angle is 180 degrees. Plus 360 degrees n. Yes? So I have two answers. Okay? So let us say that you see this in the book, you solve it, but when you go to the faucet, the answer is not this. Okay? I want to teach you that this is possible. Okay? So if you go to the faucet, if this is in the book, and if you go to the faucet, you probably will not see this, you will see this. Okay, so it might give you the wrong impression that you have done something wrong. Okay? You haven't done something wrong. Okay? What you have written here is equivalent to what the book has written, but not very clear. So we want to understand this explanation. Okay, so that is why I told you this is good to imagine it on the unit circle. Okay, so here I have two different formulas generating for me different angles. Let us see which points on the unit circle the first one generate and which point on the unit circle the second one generates. Okay, so let us see. If I ask you, tell me which points on the unit circle are acceptable. So for example, let us start from this one. If you put 0, what happens? It becomes 180 degrees, which is here. Yes?
Yes.
If I put 1, what happens? It becomes 300 degrees more than 180 degrees. It means wherever 180 degrees is, you need to rotate one full round. And then of course you return back to the same point. Yes? And then if I do that with another angle, with another number, for example 2, I need to start from here and then go 2 full rounds. And I will come back here. Yes? So this formula generates only one single point. Do you agree with me?
Yes.
So it doesn't matter in which direction you go. But this formula also generates another single point for me. What is the point corresponding to these angles? Check. If you put 0, it gives you 0 degrees, which is here. If you put 1, it is 360 degrees, is still there. If you put, I don't know, -1, it is minus 360 degrees, it's still there. So this formula generates one single point here. This formula generates another. If I ask you how many points are acceptable in total for this, what is your answer? 2. But this is good. If you are a little bit clever and experienced, you can immediately realize that you can combine these two formulas into one single formula. Okay? Because this formula that you see in the faucet works for both of them simultaneously. Okay? So if I put 0, what happens? X gives me 0, which is this dot. And if I put 1, it gives me 180 degrees, which is this dot. Yes? And if I put 2, it becomes 360 degrees, which I return back to the same point. So you see that by writing one simple single formula, you can serve as these two formulas can do together. Is that clear? So that is what I want you to understand. The notion of the unit circle is important. This is sometimes happens that you solve the problem and you find this answer, you see the faucet is this one, you think that they are different. But they are the same. And if someone asks you how they are the same, the point is that the angles generated by this one single formula is equal to the whole angle generated by these two formulas together. Yes? So if I start, for example, If I put 0 here, let us consider positive ones. So if I put 0, I get 0. If I put 1, I get 180 degrees. If I put 2, I get 360 degrees. If I put 3, I get 540 degrees. If I put 4, I don't know, 720 degrees, okay? So this formula generates these angles, and of course negative ones. But now if I ask you generate the formulas from this one, if I put 0, it gives me 0. If I put 1, it gives me 360 degrees. If I put 2, it gives me 720 degrees continued. Yes? And if I tell you generate the angles here, if I put 0, it gives me 180 degrees. If I put 1, it gives me 540 degrees, and etc. So you see that this list, together with this list, is the same list that is generated here, not each one of them individually. Okay? And of course, in mathematics, it is better to write things as simple as possible. So I also prefer not to write this and write that. So is that clear? So these things sometimes happen. Okay, so let us summarize everything and ask you one more question. Okay, let me ask you one more question. If I ask you to solve this equation, how do you answer the question? This is also important. Sometimes students get confused. I write sine x. On the right-hand side, I write sine of 72 degrees. Okay, can you solve this equation? Yes?
Shouldn't x be 72 then?
Pardon?
Shouldn't it be 72 because it's equal to the other one?
Definitely one of them is 72. But I told you that when you say 72, end of the story, it means that you found only one answer. If there are more answers to the problem, then it means that you haven't solved the problem. So when I ask you to solve, of course it is completely clear. One of the answers is 72 degrees, because if I replace x with 72, it becomes sine 72. So the other side is also sine 72, so they are equal. So 72 degrees is definitely one possible answer. But is this the whole possible answers or no? We are okay. If there are more, you have to mention all of them. Yes?
We take 72 plus 360 degrees times n.
Uh-huh.
And then another answer is 180 degrees
Minus 72 plus 3, yes? So that's the whole story. So exactly. So this is playing the role of this k. So you can write, if you want to, you can write x is equal to sine inverse of that number, whatever it is. Yes? And then plus 360 degrees n. But sine inverse of sine 72 degrees is what? 72 degrees. So it is, don't bother to write it. Yes, you just write 72 degrees plus 360 degrees n. And of course, you know that there is another alternative, 180 degrees minus that angle, which is 108 plus 360 degrees n, and n belongs to z. Yes? What happens if I give you this? Sine x is equal to cosine 40. Yes?
X is 50.
One of them. Yes. So the first thing comes to your mind is that the left-hand side is sine, the right-hand side is cosine. This is a little bit hard to compare them, but there is a remark that I emphasized a lot. Instead of cosine of 40, you can write the sine of its complement. So cosine of 40 is exactly the same number as sine of 50, and the problem is exactly as before. Now you can eliminate this in your head and say that x is equal to 50 degrees plus 360 degrees, and x is equal to 180 minus that plus 360 degrees n. Yes? Is that clear? Okay. Okay, so this is finished. Let me summarize everything. This is not in the formula sheet. I want you to have it in your notebook so that in the future you can refer to it easily. So if I have sine, let me don't write x. I would write sine of a box. Whatever inside the box is equal to k. Then if I want you to find this question mark, then you say that this happens if and only if the box, whatever is inside the box, is equal to sine inverse of k plus n times 360 degrees, or whatever is in the box is equal to 180 degrees minus sine inverse of k, and then plus n times 360 degrees, n belongs to c. So yeah, this is not in the formula sheet, so might be it is a good idea to have it somewhere on your notebook. Okay, is that clear what we are doing? Okay, so what will I teach you next? Can you predict? Yes, the same story for cosine. Yes, so I want to answer this question. I more or less use the same strategy. So if I give you, for example, 0.5, if I ask you to solve this equation, of course you can immediately read it from the table. Which angle is that? 60 degrees. But hopefully you realize that this is not the whole story. And if I want to solve this, I have to find all of them. Okay, so again, you have to start with this idea of ruler and a protractor to measure this angle. So let us say that we have instruments, instead of calculating, we want to measure things. Okay, so can you now tell me, how can I use, again, the same story, how can I use this ruler, for example, and this protractor to measure all possible angles for x? Yes, this time we can answer it. Yes.
So first you measure 0.5 on the x-axis.
Why on the x-axis this time?
Because this is cosine.
Cosine is related to the x-coordinate. So exactly. So what you do, you go and, for example, this is easy. So I measure 0.5 here, okay, on the x-axis this time. And then this time I make a vertical line. Yes. And then I get 2 points of intersection on the unit circle, and then
you draw a line from the horizontal
to these points. One of them is this angle, yes, and the other angle is which angle? Can you tell me?
360 degrees.
This one, yes. So these are 2 main angles. So the main angle in sine was that acute angle. The other one was 180 minus that angle. But when it comes to cosine, one angle is this one. The other angle is how much? Can you tell me?
360 minus.
Minus that one. Because by symmetry, the size of this angle, if I call it theta, the size of this angle is also theta. So this from here up to here becomes 360 degrees minus theta. Yes? So if I want you to tell me how can I do that, so I would say cosine x is 0.5, I have 2 alternatives. I have 2 options. So x is equal to cosine inverse of 0.5. Cosine inverse of 0.5 is this angle that you see here. But the other one is 360 degrees minus cosine inverse of 0.5, which is this angle. Okay? But are these the only angles? No, again, the same story, because if I have this one, I can go around and come back to the same point. The angle is different, but the final point is the same. So can you tell me what should I write next? Please, plus 360 degrees n plus 360 degrees n, and that's it. Yes? But this is completely correct. But usually I think your book is also not using this, because I told you that instead of saying 360 degrees minus theta, you can use a different name for it. So this is theta. So what is this angle now? Minus theta. So of course, if you write this, that is not wrong, that is completely correct, but it is easier to say theta and minus theta. You can either say theta and 360 degrees minus theta are the main angles, or simply say that plus or minus theta. Yes? So even saying it is easier in that way. So I prefer, instead of writing it this one and that one, I prefer to write this one and negative one. Yes? Okay. So I don't want to give a lot of examples this time, but I want you to formalize it for me. Can you tell me this? What happens? Something like this. If I want to write this cosine of some box, which I don't know what is inside the box, is equal to k. Yes? So what is the answer? If and only if what happens?
Plus minus.
What is inside the box is equal to
Plus minus
plus or minus
cosine.
cosine inverse of the number that you see plus 360 degrees times n. Okay, so n belongs to z. Okay, but the examples are very similar to the previous one, except that for sine you have cosine. Yes? So this is the same thing. This works the same for cosine as we had here for sine. Any questions? Okay, the last one which is left to do is what happens for tangent. Okay, well, for tangent, we want to do the same thing first. Because using this idea, we can learn what to do and then formalize it and use. Okay, so now the question is that, let me give you this question. For example, let me start with a very simple one. So tangent of x is equal to 1. So we want to solve that one. Of course, one answer that you learned in Math 1C is tangent inverse of 1. And of course, using this table, you can tell me what that number is, what that angle is. 45 degrees. Because if you go to 45, tangent of 45 degrees is equal to 1. Okay? But you probably now realize that 45 degrees is not the whole story. Yes? Okay. So what is the whole story then? So let us imagine it. So here, you realize it is 45 degrees. So one angle is here, definitely. This is 45 degrees. Okay, so if I write in front of this, x is equal to 45 degrees, but of course I know that I can go full rounds again, to the same story again, so I write 360 degrees times n is an integer. But do you think that I am covering all possibilities, or there is another angle whose tangent is equal to 1? Yes, please. 180 degrees. Yes, why is that? Because this is something that I want you to know. So if you have tangent, yes, for example, let me consider this theta. Yes, and then let us say the coordinates of this point are x and y. And now let us, instead of course, if I go 360 degrees more, I will return back to the same point. But what I'm claiming is that you don't need to go 360 degrees more to have the same value for tangent. If you just go 180 degrees more, this will also work. Why? Because if I go 180 degrees more, I will not end up here. I will end up exactly in the opposite point, at the opposite point. Yes? So this becomes 180 degrees. So in total, this becomes theta plus 180. But if the coordinates here are x and y, can you read the coordinates here?
Minus x minus y.
Minus x and minus y. If I ask you what is tangent of theta, you know it is the y coordinate divided by the x coordinate. If this angle from here to here is 180 degrees plus theta, if I ask you what is tangent of 180 degrees plus theta, you need to go to a final point, read the coordinates, and divide the y coordinate by x coordinate. Of course, both of them are different, but because both of them pick up a minus sign, then the minus signs are cancelled. I will return back to y over x. So for sine and cosine to return to the same point, you need to go 360 degrees, while for tangent, 180 degrees is enough. Okay, so from this analysis, one of the angles you found is this one. Can you tell me what is the other angle?
45 plus 180.
What?
45 plus 180.
Yes, 45 plus 180, which is 225 degrees plus 360 degrees n. Yes? Okay. But this is very important to listen to this one. This is not wrong. It's complete. But we can do more. Okay? If I give you this in the exam and you write this and or that, this is complete. You get the full mark. But can I combine these two formulas into one single formula? I erase that. You remember I told you something here. Sometimes it is possible to combine formulas into one single formula. Okay, so what can I do here? I start from 45 degrees and then go one full round. I end up here, one full round, end up here. Okay, but there is another alternative for me. It's 225 degrees, which is exactly the opposite point here. And then one full round here, I end up here, one full round, end up here. So if I use this formula, it only gives me this point. If I use this formula, it only gives me this point. Is it possible to combine these two formulas into one single formula that is able to take care of both of them simultaneously? Yes?
45 plus 180.
80 degrees, yes? So you can combine them together and simply write the x is equal to 45 degrees plus 180 degrees n. Okay, and it is always possible for tangent. So is that understandable? If I put 0, it gives me 45. If I put 1, it doesn't go one full round, it goes half a circle. So it ends up here. And then if I put 1 more, if I increase it 1, it goes back here. Increase it 1, it goes back here. And this is always possible for tangent. Okay, so in principle, can you generalize it for me? If I have tangent of a box which is unknown to me, is equal to the k, and I want to find that answer, what is the box?
Tan inverse
Tan inverse of k,
plus 1.
yes, plus 180 degrees n, and n belongs to c. So this is more or less what you really need to know about trigonometric equations, the basic ones, sine, cosine, and tangent. Yes, is that clear?
Yes.
Okay, so I told you that these are not in the formula sheet, so you have to visualize them or send them in your memory after practicing. Okay. How much time we have? A little bit. So let me give you another example. I'll choose it from the book. Okay, it's good. Okay, so this is problem yeah, it is better to write here so that we can keep the formulas. Okay, so the problem in the book, I think it's a good problem. Let us look at it. This is problem 22139. I will solve on part C. This is page 34. Okay, so the question is to solve this equation. Cosine x multiplied by sine x plus cosine x over 2 is equal to 0. Okay, so the book is considered this a level 2 problem. This will be the last example for today, okay? So if I want to solve this trigonometric equation, you see this is not a standard one. I have a mixture of sine and cosine. So far, the examples that I provided for you, just containing one of them, either sine only or cosine only or tangent only. But this one contains sine and cosine. This is the strategy that you should have in the back of your head. There is only one goal for you, to be able to reduce this single problem into one or more of the standard ones. Okay, but how, we don't know. It depends on the nature of the problem, okay, at the level of the difficulty. Okay, so I don't know, can I hear from you? What is your proposal? Yes?
Take the cosine is need to put it to the right side.
Okay.
Divide to the right side by cosine.
Okay, there is a pitfall, a very serious pitfall in this solution. Okay. So what he is saying is that move this one to the other one. It seems very plausible. It's not totally wrong, but you have to be very careful. He says that I move this to the other side and then divide by cosine, and the equation becomes very simple. Okay, and then I solve that. There is a pitfall in that, and you have to be aware of it. So if I give you to solve this equation, by the way, let me follow your strategy. In principle, if the strategy works there, it should be also working here in the simple case. So here, if I want to solve that, I move this to the other side. Yes? And then I divide by x. If I divide this by x, the answer is x. If I divide this by x, the answer is 2. Okay, are you happy with this solution? Yes? This is not the whole story. What you get is one of the answers for sure. It's not wrong. But that's not the whole story, because there is another solution for this. If you do it in that way, you miss that one. Yes, what's the other one?
Minus 2, but you can get that.
No, minus 2 is not. What is the other answer? If I ask you to solve this, how do you solve it?
Factorize x.
Factorize x, yes. So you factor x out, and then you tell to yourself that I have two numbers, the product is 0. What are the possibilities? Either this one is 0 or the other one is 0. If this one is 0, it gives me x equals to 0, or if this one is 0, is x equals to 2. So if you solve it in that way, you get one of the possible answers, not the whole story. Okay, so be careful. And this is reasonable. Why do you think this is not correct, even though everything we did is reasonable? Yes? I move this to the other side, it should work. I divide by x, it should work. So what is problematic here that I miss one solution? Because you need to understand why we are changing your strategies. You just don't need to accept it because I'm telling you this is not right. Why this strategy of dividing is problematic here? Because you see the problem, yes? If you do this strategy, I get only one answer, but you know that there are two answers. I am missing one of them. Yes?
This is because you have the same variable on two sides.
No? What is the problem with having the same variable on two sides? Nothing. But you are not always allowed to divide. Yes? If I tell you A is equal to B, okay, if I have the same amount of money as you have, if I spend half of it, you spend half of it, still we have equal monies. Yes? But so it means that in principle I can divide, if I have equality, I can divide both sides by any number I like except 0. Because division by 0 is not allowed, yes? And that is exactly the same point here. Because when I want to divide by x, I implicitly assume that x is not 0. Okay, so that's not something wrong. If x is not 0, then you can divide, and of course the answer is 2. But the x is not equal 0 is implicit in this operation. Yes? But you are so unfortunate that x equals to 0 is also an answer, so you are missing that one. So if you want to use this strategy, remember, what you simplify, if it contains your unknown, you have to put it to 0 again. So if I want to do it, I can do it, but I prefer you not to do it, okay? So you might get confused. But when you are eliminating a thing which contains a variable, you are assuming that x is not equal to 0, and you get the answer. That answer is correct under this condition. But then you have to check out if x equals to 0 is also an answer or not. Because you say that if x is not 0, I guarantee that x is 2. But if x is equal to 0 is also an answer, by checking it manually, you see that that's an answer, so you add this to your solution. Okay, but I prefer to do it like this, factorize. Okay, so anyway, so that's the idea. But because usually I don't like fractions, I don't know why, so I get rid of fractions as soon as possible. Okay, so I multiply everything by 2 to get rid of this 1/2 here. Okay, so if I multiply everything by 2, that is not, of course, compulsory. That depends to your taste, but anyway, so cosine x is equal to 0. Okay, now can you tell me what to do now? Yes?
Can we call sine x cosine 90 minus x?
What?
Can we call sine
But
x?
that's not helpful. Yes, you can, but why we should do that? So what you are saying is that instead of cosine, I call it sine of 90 degrees minus x. If you write that, it is not wrong, but I don't think it's helpful. Because what was the goal? The goal is not to start manipulating the equation blindly. The goal was to be able to go from here to one or more standard problems that we just considered. Okay? So in that case, you are making the problem harder for yourself. You're changing the angle to something else. Okay, so what should I do here? Yes? Factor x, factor cosine x. Yes? So if I factor cosine x, what happens? It becomes 2 sine x. What happens here? Plus 1 is equal to 0. Everyone understands what's going on? So cosine x is a number. So I am factoring that number out. So this is left. If you want to check it, you multiply it back, you get the same thing. So the factorization is correct. Yes? Okay, but the same story happens. This is a number I don't know. This is also a number that I don't know. But I know something. I know that when I multiply these two numbers, the answer is supposed to be 0. So this cannot happen unless at least one of them is 0. So this I call it zero product rule, okay? The zero product rule. So if I use this word, I'm referring to this. If A times B is equal to 0, if and only if either A is 0 or this symbol means or B is equal to 0. So that is the zero product rule. And of course, it will apply for more than two numbers. So the product of two numbers is equal to 0. This happens if and only if either the first number is 0 or the second number is equal to 0. Do you agree? So now let us give numbers to this. So if I want to solve that problem, I have two problems to solve. One problem is this one, so let me call it problem number 1. And the other problem is number 2. And I hope that you understand that each one of them now is inbuilt, is simple. This is a basic problem. That's also a basic problem. So let us just do it together. Okay, so because the tangent we don't need at least for this problem, but we clean it. Okay, now help me to answer the problem. So, by the way, for cosine x equals to 0, of course you can use all what I told you, but is it easy for you to visualize it? Cosine of which angle is 0? 90 degrees. Why? You don't even need you don't need the table. Cosine is the x coordinate, yes? The x coordinate of which one is 0 is here. Is there any other one? Yes, that's also here. The cosine of these two angles are 0. So that's one way. But if you want to follow the procedure, so what you write x is plus or minus, you have it here, cosine inverse of 0 plus 360 degrees n. Yes? And then you can read this from the table. Cosine of which angle is 0? You have it there. What is the angle? 90 degrees. So you can write x is plus or minus 90 degrees plus 360 degrees n. Yes? How many formulas you have? You have two formulas. One with positive sign, one with negative sign. Now again, can you combine them into one single formula? This might happen because you know that in the national exam, they might give you this and say that which one is the solution. And they don't write this, they write the compact version. Okay, so you need to understand when you solve and get this one, You need now to understand which one of these alternatives that they have presented as the options match with yours. Okay? So can you combine these two formulas into one formula? If that is my exam, it is a descriptive exam, and you're writing everything down. If you stop here, that's okay. Okay? But I'm sure that if this is in the book, you cannot see it in the faucet. The faucet has summarized it into one compact formula. Can you tell me what formula is? Yes?
Plus 90 degrees plus 180 degrees.
Yes, exactly. So you see, you already told me that these are the points. This point is the corresponding with positive 90. This point corresponds with negative 90. Yes? If you stick to one full round, you always get here if you start here, and you get here when you start here. But if you want a formula that takes this one and this one simultaneously into account, instead of adding one full round, you can just add half a round. Okay, so this can be equivalently written as one of them 90 degrees, but instead of 360 degrees, I can write 180 degrees and n belongs to z. I prefer to write this, and I'm more or less sure that this one is only written in the faucet. You can check it later, okay? This is this one. But what about the other scenario? So that was problem number one. This. Now problem number two. So what should I do now? 2 sine x plus 1 equals to 0. So, okay, can you tell me what to do? Your goal is to turn this into one of the standard problems we discussed before. So what is that? I move 1 to the other side and then divide by 2. So what happens? It becomes minus a half. Do you agree? Yes? Yeah. So what can you do now? So what is x? So you can read it from the table, minus a half. Yes? What is that angle? 120 degrees. Yes? And then plus n times 360 degrees. And the other one is what? 180 minus that angle. Yes? No, I think I made a mistake.
It's not sine.
It is, so which angle is that? It should be, you don't have it. So that's a different problem. So you want to give me an angle whose sine is equal to minus a half. That's also a big problem here. So you need to also learn what to do here. So you see for sine, we do not have minus a half there at all. Okay? So then you need to remember what I told you before. You see 1/2 there, but which angle has minus a half? Yes?
Negative 30.
Negative 30. Do you remember? Because we had this formula, sine of minus theta, do you remember? Is minus sine theta. So that's why I'm saying that just having access to the formula sheet is not useful that much. You need to know what to do, okay? So here, so I have to clean this. So minus a half for sine is not in the table, but 1/2 is in the table, and you already know that sine of minus theta is minus sine theta. So can you tell me now, if I write x, what should I write? Minus 30, yes? Not 30, plus 360 degrees n. And then you need to write what? 180 minus this number. What is that? 180 minus this number. Plus 360 degrees n. Which in this case becomes 210 degrees plus 360 degrees n. Yes? And n belongs to 0. So that is the other answer. And this is. So in principle, I have 3 formulas for the answer. Yes, is that clear? Okay. So I think we stop here. And next time probably I will give you time to practice on your own. Okay. This topic is very important. And I check if the questions in the book are not that good, I will give you some file to work on. Some of the problems are good, but not all of them, okay? Okay, so the next lesson I will not teach at all, so you will practice, and if you have any questions. So the page is 34. So we have covered everything in chapter 2 until the end of page 34. Okay? If you want to be prepared for the next time, if you have any questions, I will of course update the Google Classroom, but you can just follow. If you have any questions, you can ask me next session. I will not teach next session. Thank you. Just wait so that your head, okay, your head is now clear. I will not edit the video, okay?